Hi guys, let's take a look at this problem. Here we need to identify whether a given function is a exponential function or not. So first of all, a quick review is when do you have exponential function? Its form is this. If you see a constant times a base raised to power x. Now here's the big thing. If here in your exponents, this is it contains variable, and then here this is constant, the base is constant, then you know you have exponential function, okay? So now, if you remember previously, in the earlier chapters, we talked about polynomial. So what is a polynomial? Polynomial has this type of form. So a constant times x raised to some integer power n plus and so on and so forth. Another constant times another x raised to power m minus 1 and so on and so forth, right? So in that case, we have, oops, this is not x raised x sub power x sub 1, it's just x raised to power 1. I should delete this one, just no subscripts there. So this is a polynomial function. Now, therefore, by comparing these two, you see that for polynomial function, the variable is here. The powers are all integers. They are not variable. There's no variable on the power. Here, the exponential, the variable should be on the power, right? So, and hopefully with this discussion, you are able to identify whether this is a exponential function or a polynomial. So the key is you take a look at where the variable is located. Is that located in the power exponent or on the bottom, on the base area, right? So this is one thing. Hopefully you can identify that. Second thing is because when I look at the question, it has decay or growth, right? Growth. So how can we tell whether when you have exponential function like this form, if you have exponential function in this form, how do we know that it's decay or growth? So now just give one example. Let's take a look at this one and this one, okay? Here I'm picking the base as 2. Now if you have base 2, when the base is greater than, I have to make it a pretty general. So if you have something like this, b raised to power x, when this b is greater than 1, then you have growth, okay? Growth. When b is less than 1, but of course we always say it has to be greater than 0, then you have exponential decay. So the key is when this is just x. Now here we don't have here this is x, but this is negative x. So how can you tell? But if you think of this 2 to the negative x as 2 to the negative 1 raised to power x, okay? In this case, which is 2 to the power negative 1, which is 0.5 raised to power x, you do know that this is decay. And this obviously will be exponential growth, represents exponential growth. So so this is one way to identify. You just, when this exponent is x, you look at the base. Now sometimes when the base is greater than 1, like here, both are greater than 1, right? Which is 2. Then you can just look at your the coefficient of your variable. If the coefficient is positive, then you know, hey, it's gonna be exponential growth. When the coefficient is negative, in this case, again, provided the base is greater than 1, then you know this is exponential decay, because you can always rewrite this negative sign and then like in this case, rewrite it so that this is the base is less than 1 when you get rid of the negative sign in the exponents. So in summary, we have two methods to identify exponential growth or decay. One is when this exponent is just simply x, there's no negative sign there, then you just look at the base, right? The base, if the base is greater than 1, growth. If the base is less than 1 but greater than 0, decay. Second method is when the base is greater than 1, you just look at the coefficient of your x. If the coefficient of x is positive, then it's growth. If it's negative, then it's decay. Now, hopefully, this little tutorial provides you enough information for you to identify whether it is exponential function or not, and whether it is exponential growth or exponential decay.